Hi, today we are going to learn the intermolecular forces of van der Waals forces. At the end of this lesson, students should be able to describe the van der Waals forces of dipole-dipole forces and the London dispersion forces. In addition to the covalent bonds within a molecule, there are also other forces of attraction between the molecules, known as the intermolecular forces. Intermolecular forces are very much weaker than the covalent or the ionic bonds. The strength of intermolecular forces are responsible for the physical properties of a simple molecular compounds. We are going to study two types of intermolecular forces, which are van der Waals forces and the hydrogen bonding. There are two types of van der Waals forces. There are dipole-dipole forces and London dispersion forces. The dipole-dipole forces are electrostatic interaction between the permanent dipoles of different molecules. Dipole-dipole forces exist between neutral polar molecules. Example of a dipole-dipole interaction can be seen in hydrogen chloride. The relatively negative chlorine atom is attracted to the relatively positive hydrogen atom. This diagram shows the orientation of polar molecules in a solid. The strength of dipole-dipole forces depends on the dipole moment of a molecule. The higher the dipole moment will increase the polarity of a molecule. The more polar the molecule, the stronger the dipole-dipole attractions. For example, a comparison between the hydrogen chloride molecule and the hydrogen bromide molecule. HCl is more polar than HBr. Therefore, the dipole-dipole forces in HCl are stronger than in HBr. This is because the chlorine atom is more electronegative than the bromine atom. Based on the table, for the compound that have the same molecular mass, such as propane and acetaldehyde, have a different dipole moment. The increase in dipole moment resulting in higher boiling point. The higher the dipole moment, the more polar the molecule, and the greater the strength of the dipole-dipole attraction. Therefore, more heat energy is needed to overcome the stronger attraction between the acetaldehyde molecules. Non-polar molecules do not seem to have any basis for attractive interactions, but, according to Fritz London, when electrons revolve around the nucleus, there is a possibility that at any given instant, the electron density might be higher at one end than the other. This gives rise to a temporary dipole or instantaneous dipole moment. These forces are present in all molecules, whether they are polar or non-polar molecules. For example, in hydrogen molecules, on average, the electrons in each of the hydrogen atoms are uniformly distributed around the nucleus. Because the electrons are in constant motion, however, their distribution in one atom is likely to be asymmetrical at any given instant, that resulting in an instantaneous dipole moment. At any instant, one side of the molecule have a higher electron density than the other side, that forming instantaneous dipole in molecule A. Due to the electron repulsion, a temporary dipole on one atom can induce a similar dipole on a neighboring atom, which can cause the neighboring atom to be attracted to one another. London dispersion forces or dispersion forces are attraction between instantaneous dipole and an induced dipole. Now, let's try these questions. State the type of intermolecular forces exist between each of the following molecules. For SO2 molecule, it is a polar molecule. Thus, it has existence of dipole-dipole forces and London dispersion forces. For carbon dioxide molecule, it is a non-polar molecule. Therefore, it is only a weak London dispersion forces between the molecules. HBr molecule is a polar molecule. Thus, it has an existence of dipole-dipole forces and London dispersion forces. For methane molecule, it is a non-polar molecule. Thus, it has only a weak London dispersion forces. That's the end of our lesson. Hopefully, you can describe the van der Waals forces between the molecules. Bye!